So hi again, I'm Jan from Brno. And I would like to talk today about event sourcing. Guys, do you know what that is? Event sourcing? Okay, what that is?
Event sourcing is the general idea that things in event. So you have event communication, event dispatching, and the idea is that you can actually accumulate events to a stream and process the stream.
Okay, I'll show how, what's my point of view on that during this presentation. Now, few words about me. I'm keen in domain-driven design. Do you know what that is? No. Okay. Yeah, this is like approach that programmers do not guess what users need, but that programmers should ask users, ask their customers what they actually need, and to derive dictionaries and words they use, and then use these words and dictionaries inside their programs. So everybody then understands. I'm a big fan of this movement. Then I'm exploring event sourcing, and I will share this with you today. I'm user experience community member, so I'm just not the backend guy. I do all the stuff. And I PHP stand backer. Do you know what's PHP stand?
Yeah.
Yeah, check it out. That's awesome thing. You'll find bugs for free for you. Yeah, this is quite new talk, so feedback is appreciated. If you have some notes, paper or something, just write it down. I will be listening to feedback from this talk. Please, guys. So now we are getting to the topic. How do you store state of your application? Guys, you.
Database.
Database. Okay, what kind of database that is?
Relational.
Relational database. MySQL. Okay.
And
It depends. Okay. And what kind of database are you using, or what kind of data storage?
column based.
Okay.
So for the details in a skeleton, document based,
Uh-huh.
because some things are documents.
Mm-hmm.
Then you have the key value based, like Redis for caching and those things. Then you can go for the vectors inside of it. So you have the version vectors in VC, I think, in SQL. And I apply most of them, and then you have to convert some all of, just different ones.
That is great. So there is concurrency of different approaches. What most people actually do is they are kind of taking a snapshot of what's currently in that application and transforming it somehow and storing somewhere. That's it, right? So I have example with library. So this is a book from that library. The first thing is that this book is inventorized. So someone types information about this book into the computer. Then Tom lends this book. Then he returns that book. And then, oh, there is twice Tom. That should be me, okay. And then I will lend that book to me. So when we want to, what is current state of that book? Yeah, it's lent to Jan, yeah, okay. So we can store like this, for example. There is table of books, this one book, number 1. Users, there is Jan and Tom, 1, 2. There is table of books being lent. So for each lending there is 1 row. And returns. When also when I lend the book, there is 2nd row, right? So this way I kind of was able to store what was on that picture. And now question, which books are now lent? When you have this kind of model, you have this kind of data stored in your database, how to answer this question?
Expensive.
That's expensive, right? Yeah. And now I will make it harder. Who learned this book 30 minutes before? And what is median value of the length? So, wow, right. This can take forever, like huge database. So it's complicated. And like root of problem is that we used here third normal form. We optimized our data for writing, right? It's super easy to write. It's hard to read when we have aggregations there. There is only one point of view on data. Plus is that everybody knows this architecture, like tables and relations. And now I will show you the different approach, event sourcing. Here it is. So I have the same. Oh, it's quite. Can you read it? So now I have basically the same example written in code, and we will try to play with that a little bit. So this is the model which has been event sourcing applied. There is some concept of book, which we already know, and when I try to run this thing, look at that. There is book inventorized, and then I called book get recorded events. So it's like get whole history of this thing, and it prints what was there. So where is the type? Yeah, book has been inventorized object, right? With ID, title, and ISBN. How that works? We are now in object book, which has this constructor. I call this name constructor, static method which returns myself, and which consumes everything we need to create that object, and then it creates object and returns, right? This is probably different what you know, for example, from Doctrine. Like every time you want to mutate state of this object, you need to produce event. That's why it's called event sourcing. So basically, if I want to inventorize this book, I have event book has been inventorized. That's super simple class, just like data container. To make it shorter, I just make these public, but normally you should like write getters for them because otherwise they can be modified from outside. You don't want to do that. I just like shorten that. So this is event. Book has been inventorized. It has ID, title, and ISBN. And I get back to book. So it's created here with all the values, and then on me it's called record that. It basically does just this. It saves this event into array, which is inside that object book. And then I can get all these events from by calling this method, right? So when I make it a little bit more real world, we can add lend to. So book can be lent to someone. I will just like pass the ID of user here because it doesn't need to care about it much. And there is again code like this recorded book has been lent. So, but there is, it works like, I will just run this, it works. Book has been inventorized, book has been lent. Right? Problem is that when I try to lend this book again, for example to another guy, it will work. And that's bad, right? Because now the book is lent to 2 people. So how can we fix this? Any ideas?
You write the condition is already somewhere that the other person is doing.
Great. Yeah, let's do that. So I'm now in object book, where there is method lend2, and there should probably be some exception when it's already lent, right? But how to actually check that it's been lent when there is just these events? There is, let's break there. When you call record that, there is method apply called. So it basically applies every event on this object book, and you get in the current state. So you conceptually always start from the first event which happened, and then you apply one event at a time till you get into current state, into now, right? So, and there is little magic here, which will just call apply and name of event. So basically you just have a bunch of these methods, and I can now basically create some kind of state which I need for validation of invariance in this object. So let's make it. So let's make some state here. What we need to know if we want to restrict this behavior, we don't want to have book lent to more people. What is minimal state we need here? Yeah, if, but we need some data like on which we can.
It's been done. Yes or no?
Yeah, okay.
Or who it's,
Maybe who, but I think we probably don't. Yeah, we need who, because if it's lent again to the same person, then we don't care, right? Let's say. So we can create just some field here. Lend2. What will be type of this? User ID or null, right? It's not lent to anybody. And then we have this apply methods. If you remember from slides, it's the events are like the first is it has been inventorized, then it can be lent to somebody, and then it can be returned. So when it's inventorized, it does not change anything on who it's lent to, right? Doesn't matter. So the first event which is interesting to us is book has been lent. So here in this event, I will just assign lend2 event lend2, because there is in that event is stored who has been lent to. So I will just copy this value, and if it's returned when book has been returned, I will just delete this value. Now this is done. Now we can check invariance. So this lend2 is null. It's not null. Then you already lent.
Or it's not the same ID.
Okay. Oh no, if it's the same ID, then we will just return, because there is no need to have another event here, because
So if you need it to the other person, you will have the same exception.
Pardon?
we have null or a different ID. That's basically our condition.
Yeah, I can make it like.
We can do both of them in separate lines, of course.
Huh. These are objects, so I will use this and return. Just do nothing. Okay, so now let's play with this a little bit. It should explode right now. Yeah, it exploded. But on something different. Why? Call to member function equals on null. Okay. Wrong order. No, that's wrong also. No. Any idea how to fix this? Yeah.
This won't work either.
Why?
Why is this equals?
Because we will never get to the second condition for the check because already null.
This needs to be first.
Yeah, okay, it needs to be first. But now there will be no null because this can't be null. Yeah, okay, so finally we got it. Hopefully. Oh my god. What is happening there?
This will be the same error. We still have the null issue. We have to check null first.
What's this equals?
Hmm?
You need to combine the condition if it's not null or.
But now I will don't get that error. There is something different happening
No,
here.
it's an and, not an or. Because obviously the second check will be
Okay, okay. No, it does not work. Why? Okay, so I will just leave this alone. Conceptually, you just like build the smallest state you need to check if it's been lent or not, and then you throw exception. But I've just bumped into some bug there in this demo code.
That's a very good question.
Mhm.
When you first created the book, when you evaluated the book, you didn't store the title and the ISBN within the object. Is it just for the sake of the demonstration, or is it intentional that you store the attributes only in the event and not within the object itself?
Yeah, why I haven't stored that inside of the object? That's a great question. I can definitely store it there if I need it for something.
Yeah.
But the idea, which I will show later, is that we actually don't need this. Because, like, question to you, do you need title of the book to actually decide something on business process in this code? Like, no, you don't need to do this, right? You need to have this title and ISBN in list, but you don't need like anything. It's not business domain related. So that's basically it. You just need like this. You just need data which are business related, and you then decide which path you go through your code. That's it. Yeah, it's just continuation of the example. So another thing, like, what does your model consist of? I'm asking about your model because usually people answer me that there are just data. But there is also behavior. And interesting about event sourcing is that you actually store behavior and not data. Because from behavior you can always derive data, right? So the idea of event sourcing is that we will store that book has been inventorized, it has been lent, it has been returned, and then it's been lent to someone else. And we can always derive current state from that. That's basically the thing. it forces you to model all your model state transitions explicitly. Like, if I, for example, don't have use case for renaming book, it will be just not possible to rename it because there will be no event which will actually change the title of the book. So this can be quite tricky if someone makes typo, for example. You have to think about these use cases. Interesting is that then structural model, those tables in your MySQL or documents database or whatever, are like secondary because you have this stream of events and you can derive whatever you want. There is emphasis on behavior. And the series of events, which I've shown you, those 3 events, which was printed on the console, are called event stream. Event stream is immutable. Once you save event there, it's there forever, conceptually.
GDPR.
That's a great thing, great question actually. But like, it depends how you implement it. Because when, for example, I have this model with books, this is completely GDPR compliant. Because when I just reference user ID, that's fine. Because then I can, and users can be in normal table. So I can just like delete them or, I don't know, replace name with dashes or whatever, right? And I have no problem with that. So it depends on how you implement this. Cool thing is that you have natural outlet log. Like, everything what happens in your app is always in that log. Because events are immutable, it behaves like this. Yeah, and there could be thousands of these event streams. Like, every book has its own event stream in our domain. Another thing. Do you implicitly delete your data in your apps?
Depends on the data. If it's a mapping, I implicitly delete all relations because I don't need that relations, for example. So it also depends on use case.
And what about when you, for example, rename book in your table, then you unintentionally deleted the original name of the book, right?
So relations, the groups of the relation data.
Yeah, sure. But like every update is also kind of losing data, right? So I don't do that because I use event sourcing in some apps. This is another example of like another domain. So it basically looks like this example. You get into some state, and when you want to delete something, you just publish another event that something has been deleted. So whenever you need to like do undo, just like delete it and undelete it, you just get a few versions back. So you can basically see deleted data if you want. And now, can you imagine that we will be searching or reading in this kind of database, that we have like thousands of event streams, and we want to answer that question I have at the beginning, like what is median length of length? Like that would be really hard, right? Because I basically had to read the whole database into memory and then do some operations on that. That's like nonsense. But what if demo? What if we introduce something which what is called projection? I don't have implemented. In this example, I don't have a persistence layer implemented, so I will just like show you how, what's idea here. So book has been inventorized, and then there exist two users, book was lent to the first one, then it's returned, and then it's been lent to the second user, right? When I go through events which are produced, I will have 4 events that have been inventorized, lent, returned, lent, right? And now I want to implement this function. Who has the book? Which consumes book ID and returns the user ID or null if it's not lent to anybody. So how to do that? Basically, you can set up long-running process which looks approximately like this. This is like your data pipe, which brings you all new events from the system, and then you basically have 4 each, because for all events you just do this, which is that when book has been lent, I will just set some variable to something. This can be written to disk, for example, or to database, or it can be table or whatever. Document database are usually used for this. And when it's been returned, I will just reset this. So wherever, and then wherever, whoever will call this function, it can just use, let's say, like this, len2, and return that value. This obviously nobody will implement this like this. So we can use, for example, files for storing this state. File put contents. And there will be book ID, event ID, and we will put data inside of this. So it's now when I run the script, I should end up with a file which contains current state of the domain, right? And accessing file is super fast. So you basically end up with these processes running asynchronously from your app, which are basically syncing your domain state with these projections, and you can read from them. In like real world, it looks like this. Now this is our app, which we are developing right now. There is some table with this horrible name, which stores our events. So here is event ID, event name, and payload, which is serialized version of that event. There is ton of these, and then there is a bunch of tables. We have like around 10 projections to have like more point of views on the same data. So for example, when I have this table which is generated by some projection, I can delete something. You usually don't want to delete your production database, but with event sourcing you can. Because how to delete row? Like this. Delete row. Write to database, right? They are gone. But now, wait a second. I will run projection, run all, reset. It just wipes the database and recreates everything from event stream. Right, that's the same thing I've shown you with for each, but in like more real world. Now when I refresh this data grid, how to refresh this? Okay, I'll close it and open again. It's the error, right? So cool thing is that you can add like whatever projection anytime in future, and you still have all your data. So that's basically the point.
Yeah, but this takes a year in real life, doesn't it?
Pardon?
This can take a year, doesn't it? Because the event database, event table is endless.
Yeah, it can take a lot of time, but you can parallelize it, right? Because, yeah, conceptually it looks like this. It's just like reading one by one and updating some tables, right? That's what it does. And I want to show you this. Then if you have event stream, in event stream you have events, which has serialized like version of it. You can stream it over HTTP, for example, into like 10 data centers. So the scaling of this system is like almost infinite. So as you asked me, like if it would take a year, yes, it can. But you can basically run for each event stream one process, and you can have like how many servers you want, right? And a cool thing about this is that, for example, when you're upgrading application, you can like pre-compute the new version of projections, and you can have still the old version running, like because you have it like the main source of proof is the event stream, and projections are just secondary. They always catch up with like the current state.
But you need the projections if you want to lend the book. Mm-hmm. You have to check first if it's there.
Yeah.
So when each customer walks up to the desk, I have to fire up the engine.
Not really. Not really. If like the domain model, the first thing, the object book I've been showing you, it actually conceptually reads the whole event stream always, each time you want to write something to it. So it has always up-to-date data, even if projections are not up-to-date. If it's slow, like if you have like millions of events in one stream, then you can do something what's called snapshotting. So basically like save the state of that book object to disk, and then when you load it, you just like continue reading what's new there from last time you read it. So there are ways how to optimize it, but it can get quite easily tricky when you start doing this. But I actually never bumped into this, because if you design your application the way that you don't have millions of events in one event stream, then you don't need to do this.
What is one event stream? I mean, how many event streams do you have?
That's an awesome question, but this is for another talk. Because like how to actually make these smaller or small, that's the whole that's what's domain-driven design about. So it's more like design decision, and there's like a lot of things you have to consider, and also how the business is actually structured. It usually copies like how the business works. So like this is not a technical question. Basically, if you are, for example, if you are doing
so in the book library example, lending and returning is one event stream.
Yeah, it's one event stream. Yeah, exactly.
But outsourcing the books to somebody else, to some other, whomever, is another event stream.
I don't know what do you mean by outsourcing.
Or buying.
Yeah,
or whatever.
Yeah, that's probably a different domain.
Yeah.
So you just have like separate event streams for the. If you decide that you want event source this. Yeah, sometimes you don't need it. In our app, we have like 5 subdomains, and only one is event source, because all others are like not the core thing what we care about. So others are just like tables. So here, when you are reading through this stack, it can be like third-party API, it can be analytics engine, like all up cubes and this kind of stuff, and projections. in general. Who is using that? LinkedIn, for example, BlaBlaCar.
Redux.
Hmm?
Redux.
Yeah, that's the same idea. Yeah, but they just usually don't persist it. But idea is the same.
Yeah, you can actually, but
Yeah, sure, you can. Yeah. Yeah, it took me about approximately 2 years of studying to actually like build something which is like, you know,
Kind of works.
not kind of works. It worked also before, but you know, to get things right and like not too big and not too small, right? That was exactly your question. Like, so you have to try this few times. You will miss because it's quite complex. But I want to share a few sources which help me to get where I am now. And that's this book. That's about domain-driven design. There is no event sourcing inside, but this book has answer for you. How big should the event stream